In this video I'll show how to use one particular diagnostic routine in SpecView to check for comms overloads and other parts of SpecView that might be requesting too much data and therefore causing a bottleneck. There's a saying that to make things go faster you need to go slower, and we'll see what that really means a little later on. Now the first thing to notice, while the system is running normally, my system isn't running normally because I've got no instruments attached, but when the system's running normally, have a look at the bottom right hand corner of the SpecView screen where it shows in my case, the value 0.0 pps, that's points per second. That value is tied to mouse movements. If the mouse moves it shows X and Y, but if you leave the mouse alone for 20 seconds it shows the points per second. So the first thing to do is to just hang tight for 20 seconds, have a look at the points per second and make a note of what that actually is. So once you've done that, we then need to do the diagnostic routine, which is File, Preferences, Debug tab, and in the Repcode field you type in 568. When you click OK, it generates a file and automatically loads it into Notepad or some other editor. Let's make that fit on the screen. Here we go. First thing to do is scroll right to the bottom. At the bottom there's usually a section that contains all these 90 million numbers and the word SpecView lots and lots of times. These are all the SpecView user variables, so we can ignore those because they are not real comms. So we scroll up until we reach the next section. So the first thing to look at, as your first clue, is points per second required to get all the above values is 61.3. So the way that all the screens have been configured, the trend charts, the strategy controller, whatever the logging, SpecView needs on average 61.3 points per second to get everything that you have asked for in the configuration. So compare that against the PPS figure down there. I just lost it because of the mouse, and you can immediately see that there may or may not be a problem. Typically for 9600 baud serial communications you could expect between 28 and 34 points per second. This particular configuration has a bunch of serial slaves on the back of two TCP converters. One of the converters is at IP address 200, and we've got slaves 6 and 5 and 3 and 2, so there's at least 4 serial slaves on the back of one converter. If those serial slaves are at 9600 baud, then again you could expect about, well, probably 26 to 28 points per second because it's over TCP/IP. So scrolling up to the top of this particular section where it says interval list, if you've got more physical serial COM ports, there may be different sections, each with its own PPS. Here we go. What does all this meaningless rubbish mean? The most important thing is to look at the second to last number on each line. So in this case it's 1111 and then 20, and as we look down we'll see some 5s. So this is the scanning rate in tenths of a second. So this means that this particular variable here is being asked for at a rate of 1/10 of a second, or 10 times a second. These are 20 tenths, or 2 seconds each, and this is 5/10 of a second, or every half second, or twice a second, depending on which way you look at it. Ignore the number on the end. So this second one that's interesting. So where are these coming from? Well, typically 20 is probably the medium rate. We can have a look if we go to File, Preferences. Here are the various assorted rates. So the medium scan rate is indeed 20 and the ultra high scan rate is 5. So if we look back at that file, just make it a bit less wide. So these 20s, fairly obviously medium rate stuff. Where are the 5s? Here's a 5, that's probably something set at ultra high scan rate. If we look down, there's some 600s, which would be the logging rate, which tends to be twice this. So the logging rate is 120 seconds, it's actually scanned twice as fast as that. 60 seconds, that gets you 600. So we understand where 600 comes from, we understand 20, we understand 5. Where are these 1s coming from? Why is there a scan rate that's 10 times a second in this configuration? bear in mind these 4 values here, 10 times a second, that is 40 points per second sitting right there on those 4 things. Now, I mentioned earlier, to make something go faster you should slow it down. The reason for saying that is these things at 10 times a second, it's all very well, but sometimes it needs to ask for all these things every 2 seconds. So every now and then, hopefully every 2 seconds, but you never know, SpecView will request all of these items. Now I've just highlighted maybe 20 of them. So while SpecView's getting these 20 values, that's going to take almost a full second to get those, during which time these things, well, 10 times a second, it's going to take a full second to get this lot. Those aren't really being requested that as fast as you think they are. Or conversely, because most of the bandwidth is taken up with these 1/10 of a second ones, these guys are actually going to struggle to get any time. Certainly these guys at 5. There's a clue as to how far down this list things are as to when they're next going to be requested. The things at 1, they're at the top of the list, they're the next things to go. Then there's a bunch of 20s, then there's a 5, some more 20s, some more 5s. So these things that are apparently at the ultra high scan rate of 5/10 of a second are actually queued behind all of this lot. Let's go down to here. So here we've got what, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Probably about 32 other values need to be got before these 5s go off. If it was 30 points a second, it's going to take over a second to get round to this, which is hopefully going off twice a second. So we've got a problem. This system is severely overloaded. How can we find out what the variables are that are causing the issue? Well, I'm going to concentrate on this one for a moment. This one at half a second, this thing behind the IL is SpecView's unique identifier on the variable. So that's 80,010. So back in SpecView, if we go offline, invoke the variables list. So we don't know where it is, so let's go options find and type in 80,010, which is not the name of any variable or parameter, it's the unique ID. If we click find, there it is, process value. So it's this instrument F2 cont process value is being requested twice a second, which is not unreasonable. So that's cool. So let's look at the real problem in this particular configuration, and that is at the top we've got these things set to 1/10. Where are they coming from? What's going on? They're not at the medium rate, they're not at the ultra high rate. What's causing them to be at 1/10 of a second? Well, if we just nip back into runtime, there's a trend chart on this screen which is quite wide, and it looks like the elapsed time is 30 seconds. So this trend chart is a time of 30 seconds for such a wide chart. So let's just do a setup on this chart. Have a look on the chart tab. It's a no scroll rescale time to fit chart whose initial duration is 30 seconds, and because of that 30 seconds, SpecView needs values for each pixel every 0.1 seconds. So there's the 1/10 of a second. It's also got intermediate values for zooming of 2. Well, you can't get any faster than 1/10 of a second, so that's also 1/10 of a second. So this trend chart with its 2 values on is requesting 20 values every second, and I happen to know in this configuration there are 2 other screens also with 30-second starting charts. So that's where these ones are coming from. So when SpecView starts in this particular case, these trend charts start off at 30 seconds. It's absolutely killing comms, causing everything else to be slowed down. So to make it go faster, we need to slow it down. if we were to change the initial duration of these charts to 10 minutes, we can see the change in the update rate. That would cause values on the trend chart to be requested every half second, but actually again intermediate values for zooming, 2 of them, so it's still only basically halved the rate. So from 1/10 of a second it's gone down to 2/10 of a second. So if we made this 20 minutes, we're now down to 0.3. Whatever settings you require here depends on the configuration and the requirements of the customer, but just to be warned, that's what it is. If these processes typically last no less than an hour, say, why not make the initial duration an hour? Now we've got 3 seconds for the normal pixels and 1 second for the zoom values. So by making those changes, you can change what was 20 points a second down to just 2 points a second, with no real difference to the user because all their processes last an hour. So just bear that in mind. So by making those changes, you can then do another Repcode 568 to see what effect that has. Let's try that. I need to close the original one. Close. No. File. Preferences. Debug. 568. Let's make this fit. Scroll to the bottom. Scroll up past the user variables. Still 62. This looks like it hasn't changed, but this 19 might be the giveaway. As I mentioned, there are three trend chart screens. So these are the other 2, and this is the one that I've changed from 30 seconds to an hour. So there is a change, but we're still overloaded because of the other 2 trend charts. So if I was to change those as well, we'd probably have a system that was considerably less overloaded.